So today for your guest teacher, you guys are just going to watch this video, and I hope you're able to understand the concepts I'm trying to show you. We've covered so far order of operations, and we've covered so far substituting values into expressions, and so today we are going to talk about combining like terms. If you don't understand it after today, that's fine. Since it is only a 45-minute period, I'm just trying to introduce you guys to some of it, at least for now, and then we'll talk about it more next week. So we're going to start with some vocab for now. If you open your foldable, you have variable, coefficient, and constant. So some of you have your own definitions for each of these. You've learned different things from other teachers, but not the official ones, but the ones I will tell you. A variable means a quantity that may change. Okay. On the right side here, I'm sorry, this is supposed to be a 4x plus 5. It got cut off a little bit. So on the right side over here, your variable is your x value, okay? The x value could change and be replaced by some other number. We've seen this, we've practiced it. You did it for your homework before the 4-day weekend. If you need to pause, I'm pretty sure you can pause these videos. A coefficient is just a multiplier placed before a variable. Okay? In this example, your coefficient would be your 4 because it's before your variable. Okay. So not only is your 4 before the variable, but it also means that whatever you plug into your variable, you're going to multiply that by 4. So if I told you x equals 3, then you would plug in 3 to the x, and then you would do 3 times 4. Your coefficient is just your multiplier. And my constant is just kind of like how the word says, it stays the same, nothing changes about it. It's a fixed, which means it stays the same, a fixed value slash the number is on its own. Okay. And in this problem, the coefficient, I hope you are able to tell me, is the 5. Now, you need to always include the operation that's before a number. So if this was 4x minus 5, your constant would be negative 5. But this is 4x plus 5, so your constant is just 5. Value will not change. Sorry, I didn't notice that it was cut off. The constant is 5 because that value will not change. Okay. So, we're going to move on to combining like terms examples. Some teachers show this with fruits, others show it the color coordinating method. I personally will show you guys, because I like it this way, just the color coordinating it, but I will also tell you how to just visualize it with fruits, and then hopefully you can choose the way that you like best. So when we open up to the next page, to combine like terms means to join together expressions that contain the same, okay, if you want to put some color to it, sure, the same variable or variables, that's what that means, with the same exponent, okay? You cannot join together x with x squared, because although they are the same variable, they do not have the same exponent, right? Your exponent's right here. This one is a 2. This one is a 1. So you cannot join these two together. Sorry for blocking the screen. Cannot join them together. So your first step to combining like terms is to identify the matching families. That's where I use different colored pencils. So if you want to use different colored pencils or different pens or highlighters, that's up to you guys. And then you join them together, and then you just simplify. You'll see what I mean. So my first example is 4x plus 3x squared plus 6x minus 1. I want to identify the matching families. Matching families have to have the same variables with the same exponent. So here, I'm going to use blue, and it might show up as black. Here I have 4x, that's blue, okay. I'm not going to write blue with my 3x squared, because although they are the same variable, they are different exponents. So I'm going to change it to red, plus 3x squared. Now I have x here again, which matches here. They are the same variable and they have the same exponent. So I'm going to write it in blue again, plus 6x. And then I'm going to write my constant as a different color because my constant doesn't match anything. So I'm going to do minus 1. So now I have 4x in blue, plus 3x squared in red, plus 6x in blue, and minus 1 in purple. Now from here, all you do is you just combine the families. This is where if you need to picture them as fruits, you can do that as well. So in order to combine them, I would do 4x plus 6x, which is just 10x. You leave your variable the same and you just add your coefficients together. Or you can picture it as 4 oranges plus 6 oranges means that in total you have 10 oranges. Now, I bring down my other ones, plus 3x squared minus 1. These are all 3 different colors. They're all 3 different families, and so I can't combine them. I can leave my final answer as this, but the more technical way that people do it in the math world is you just go from biggest to smallest exponent order. So this would be 3x squared plus 10x minus 1. You go you go 2, 1, and then this is the same thing as just kind of saying 1 times x to the 0 power. Anything to the 0 power is 1, and 1 times 1 is still 1. And this would be your final answer for this one. The next one, I'm going to color coordinate again. I have 6x squared minus 3x plus 7x squared plus 5x cubed. And I'm sorry, I think I missed the cubed part here. So, color coordinating it, this and this, these two are part of the same family. So I'm going to write it in green. 6x squared, and then these two are part of the same family. They have the same variable and the same exponent. So then minus 3x cubed, I'm going to go back to green, plus 7x squared, I'm going to go back to red, plus 5x cubed. And then I just combine them. 7 plus 6 is 13x squared, or you could think 6 apples plus 7 apples means 13 apples. And then I rewrite minus 3x cubed plus 5x cubed. I can combine these two, which just leaves me with 3x squared and negative 3 plus 5 is the same thing as saying, oops, excuse me, plus 2x cubed. And like I said, you could leave it as this answer, but if you want it to be more precise, you would write 2x cubed plus 13x squared, and you can't combine anything else. So this is your final answer. And the last one. 7xy plus 5x squared minus 3 plus 6xy minus 4. Multiplication in these problems is the glue. It's what holds it together. So this is 7 times x times y. This doesn't have a y, this doesn't have a y, this does, and this doesn't. So your two families here would be this one and this one. These two match. They have the same variables held together by multiplication and the same exponents. So you rewrite it. 7xy. And then 5x squared, I'm going to write it in blue, and that doesn't match anything else. So plus 5x squared. And I might run out of space here, so I'm going to cram it up a little bit. I'm going to do my constants in green, minus 3 and minus 4. So minus 3. I'm going to go back to red, plus 6xy. And I'm going to go back to green, minus 4. Now I just combine them. 7xy plus 6xy, or 7 watermelons plus 6 watermelons, is the same thing as 13 watermelons. And if you want to cross them out, because that helps you visualize better, go right ahead. And then I can combine, or actually I can't combine my blue with anything. So I just bring my blue down, plus 5x squared. And then I can combine my green. Negative 3 minus 4 is just negative 7. And that is my final answer right there. Okay. And lastly, I hope you guys are able to understand, but like I said, if you don't worry about it, because we'll talk about it next week as well. Just try to follow along and copy the notes at least. And lastly, we have the distributive property and combining like terms. So the distributive property simply means to change each expression by the same value. It's kind of like a coefficient, but not quite at the same time. So the keyword here is distribute. Some of you guys may hear your teachers say, I'm going to distribute this chocolate bar to everyone at the end of class. I'm going to distribute these tests to everyone at the end of the quarter. Distribute simply means to give. I'm going to distribute this test to everyone. I'm going to give this test to everyone. So the distributive property. We have 4 times 3 plus 2. Some of you could do order of operations automatically. And you could say, oh, this is the same thing as saying 4 times 5, because 3 plus 2 is 5, and 4 times 5 is 20. But when you deal with the distributive property, it's not always that easy, because sometimes we get thrown in expressions that we can't combine. You can't combine 3x and 7 together. So the distributive property means you're going to give each expression that 4. So I'm going to rewrite it as 4 times 3 plus 2. And all I do is I give it with multiplication. So 4 goes to the 3. So 4 times 3, which is just 12. Now, we need to keep the symbol that is given to us. If that's a plus, then we rewrite it as plus. If it's a minus, we rewrite it as minus. And then we give that 4 to the 2. And try to choose a different color, blue. We give that 4 to the 2. Now 4 times 2 is 8. And 12 plus 8, it should equal 20. And that matches the original answer. 4 times 5 is 20. 4 using the distributive property still gives us 20. So that should match up. So this is where I said sometimes they don't always give us easy ones. Here you're going to give that 4 to each expression as well. So you would do 4 times 3x don't forget that plus. Whatever symbol they give you, you bring it down with it. Plus, then you do 4 times 7, which is 28. Now, we know that multiplication is simply repeated addition. So if you wanted to rewrite this to help you visualize it as 3x plus 3x plus 3x plus 3x, 3x 4 times, and then plus 28, you know 3 oranges plus 3 oranges plus 3 oranges plus 3 oranges is the same thing as 12 oranges. Or you would just do 4 times 3 is 12, bring down that x. 12x, bring down that plus, and then bring down that 28. Can you combine anything else? And your answer should be no. And that is your final answer right there. What we are doing right now is simplifying these expressions. We're not solving for anything. I didn't tell you what x is. All I said is to simplify them. So you're just making them look prettier, in a sense. Our final two, you bring that 6 and you distribute it to each and every value. 6 times 2x, you could do 2x plus 2x plus 2x 6 times, or you can just do 6 times 2 is 12, and that x, 12x. You distribute that 6 to the x squared. Don't forget to bring down your symbol, minus. And 6 times x squared, you could do x squared plus x squared plus x squared 6 times, or you can do 6 times, and there's always an invisible 1, remember? If there's no coefficient in front of a variable, it's just 1. So 6 times 1 is 6x squared. No, excuse me. My light's turned off. And then you distribute that 6 to the final number, which happens to just be 1. Don't forget to bring down your symbol, plus, and 6 times 1 is just 6. All three of these are different families. These two have the same variable, but they have a different exponent. So I can no longer simplify this. The only thing I could do is rewrite it so that it looks proper. When we rewrite, this is flashback to our functions, you bring the symbol in front of it with it. So this now becomes, let me choose a different color, negative 6x squared plus 12x plus 6. And that is our final answer. I'm going to work this one out, but see if you can just pause the video and try it on your own. If you still need to follow along with me, then go ahead. You do 5 times 2x, 10x, bring down your symbol, 5 times 6x is 30x, bring down your symbol, and 5 times 3x squared is 15x squared. So now you could have either combined these at the beginning and then distributed, or if you distributed like me, now you combine them. 10x minus 30x. These two have the same variable and the variables have the same exponent. So 10 minus 30x is just negative 20x plus 15x squared. Okay. So, if you need to re-watch the video till the end of class so that you understand this better, go ahead. If you feel like you understood this enough to start your homework, go ahead as well. And we'll go over it next week.